Koç University İşBank Center for Infectious Diseases has some significant features. We are officially founded in the middle of the pandemic, but based on 10 years of experience in infectious diseases and clinical microbiology in Koç University. Being in Koç University provides us great advantages of interdisciplinary studies, including structural biology, chemistry, physics, engineering, applied mathematical studies, and computer science. We are located in the middle of two continents, Asia and Europe, and also well connected with the rest of the world, like Africa, America, and Asia continents. Therefore, the center has excellent logistic support to perform international collaborative studies and all kinds of activities. We enjoy having the synergy of three departments: infectious diseases, clinical microbiology, and public health, working for the same goal altogether, so that we are enthusiastically dealing with challenging public health threats in infectious diseases field with great curiosity, courage, and confidence.
Microbiology laboratory is the core of our center. The laboratory involves research areas which are antimicrobial resistance and bacterial pathogenesis, biofilm research, fungal research, and the last part, viral research in BSL-3 laboratory, which is activated in 2020 during COVID-19 pandemic. The main theme of our work is the emerging threats in clinical or public health concerns. In this aspect, our collaborations with clinical and public health researchers become very important. Currently, there are several projects ongoing in our laboratory. Related to viruses, we work on neutralizing antibody and T-cell responses in different patient populations infected with SARS-CoV-2 or Crimean-Congo hemorrhagic virus. Also, antiviral studies against both viruses are in progress. In bacteriology section, virulence traits of MDR, gram-negative bacteria, particularly Pseudomonas aeruginosa, Klebsiella pneumonia, and Acinetobacter baumannii, molecular epidemiology of antimicrobial resistance, nanoparticle-based therapy options for MDR pathogens like PDT or PTT therapies are also in our interest.
Public Health is one of the three departments within Koç University İşBank Center for Infectious Diseases. The working model of these three departments is an exemplary model in terms of building a bridge between basic sciences, clinical sciences, and public health. You can think of this collaboration as the reflection of the research results produced in the laboratory on public health, or as the transformation of priority health problems in the society into research questions to be conducted in the clinical and/or laboratory. We also developed this working model especially in terms of student research in undergraduate and graduate education. Within the scope of our Global Health Masters program, which is the only one in Turkey, we provide joint research consultancy to both undergraduate medical students and graduate students.
We are in a laboratory where new and advanced techniques are applied in infectious diseases. In addition to being able to culture many viral agents in our BSL-3 laboratory, here we also carry out metagenomic studies, microbiota studies, and molecular epidemiological studies with our strong molecular infrastructure. These studies produce valuable scientific publications and turn into products such as point-of-care diagnostic tests.
In the Fungal Research Laboratory, we mainly focused on antifungal resistance studies on Candida parapsilosis and Candida auris, which are the emerging fungal pathogens in Turkey and also in Europe. Here, we conduct nationwide multi-center projects on azole and echinocandin resistance in Candida species. Also, we study antifungal resistance in Aspergillus species, isolated from clinical and environmental origins.
To me, modern medicine is all about antibiotics. And antimicrobial resistance in bacteria and viruses is a serious threat. A problem is so serious that it threatens the achievements of all modern medicine. A post-antibiotic era in which common infections can kill minor injuries far from being an apocalyptic fantasy. It's instead a very real possibility of the 21st century. Here we have developed beyond the state-of-the-art disruptive high-resolution imaging techniques. In a sense, we are the Pixar studios of biology. We can image biology at near physiological temperatures, and we can bring the biology alive. Here in this center, Our group is responsible for atomic level imaging of antimicrobial and antiviral drugs with their targets, so we can develop new generation therapeutics against emerging infectious diseases such as COVID-19. What this center accomplished in such a short time is absolutely remarkable, and I cannot wait to witness the future accomplishments of this remarkable team.
Organoid technology is now used in different research fields, including infectious disease modeling, host-pathogen interaction, and the patient-derived organoid biobanks. In our BSL-3 laboratory, we are working on the generation of 2D-induced pluripotent stem cell and the 3D organoid for modeling infectious diseases, in particularly in SARS-CoV-2 and the Crimean Congo hemorrhagic fever. We aim to better understand the pathophysiology of CCHFV and the SARS-CoV-2, test different candidate drug efficiency, and study the cellular tropism.
I'm working at QICID as a postdoc. My research areas are bacterial resistance and nanoparticle-based therapy approaches against biofilm-related infections. I'm a postdoctoral researcher at QICID. I'm doing my postdoc is a continuation of what I did for my PhD and its development. My PhD thesis focused on Pseudomonas aeruginosa infection and the investigation of their resistance mechanism and the virulence profile at the molecular level. We detected differences in the iron uptake mechanism of a certain group of Pseudomonas, which is one of the most important virulence factors that play major roles in its pathogenesis. In our new supported project, we aim to find the new treatment approach to target iron uptake system, resolving the structure of the systems by examining in the both molecular level and the protein level, give us to identify new target sites for antivirulent and antimicrobial therapy for multi-drug resistant Pseudomonas aeruginosa infection.